Antarctica, I sent you an article. It's just following up with your I thought I could follow up with your climate tipping points, just the loss of sea ice and ice shelves and what's going on. It says the title of the article, Antarctica, 60% of ice shelves at risk of fracture, research suggests. Collapse of shelves would accelerate loss of Antarctic ice sheet and increase sea level rise. So just essentially, 60% of Antarctica's ice shelves could be vulnerable to fracturing, increasing sea level rise, like I just said. And then they talked about something, I wanted to know if you heard of it. It's called, a study published in the journal Nature has mapped areas where ice shelves hold back upstream ice and are susceptible to hydrofracture, where meltwater flows into crevices and fissures in the ice and enlarges them, potentially triggering the collapse of the ice shelf. So what's going on with Antarctica? They've had extreme temperatures, and now they're talking about hydrofracturing of ice shelves.
Well, basically what's happening, if you have any like crevasses or any little crack that appears in the ice, if you have any meltwater that can flow into that crack, and depending how deep the cracks go, that water will eventually freeze. But remember, when water freezes, it expands. So that expansion could give the ice a kick to help break it apart, is basically what's going on there. Yeah, basically what happens, if you have any little cracks, it depends how deep the cracks go, you get meltwater that flows into those cracks. Well, that water will eventually freeze. But what happens when water freezes? It expands, and that expansion will push the ice apart,
so
thereby helping to fracture the ice some more.
Which leads to sea level rise, is the point of the article. It's just the point of no return, essentially.
If you get enough of the ice that breaks loose, that leaves the land, gets into the ocean currents, makes it into warmer regions, yes, that ice melts and will contribute to sea level rises. Another thing is, and this is like, particularly with like the Thwaites Glacier, is that if that thing lets loose, and I just saw a paper, haven't looked at it in detail, that they say it's with an imminent threat of collapse, total collapse. If that flops into the ocean, then the Pine Island Glacier is not too far behind it, and that will go in. And then you have the Brunt ice shelf, you've got the Ross ice shelf, you have all these major ice shelves that are vulnerable. Now, there's another thing called the grounding line, and this is where the ice like rests on the bedrock, because a lot of the ice extends past the bedrock and is out over the ocean. So if something happens where it cracks it, it could then split off from the grounding line, and then fall into the ocean. So that can come from increased air temperature. It can come from increased surface temperature of the water, where it melts it from below and weakens the ice that way. So there are a lot of physical processes at work here that can undermine the integrity of the ice.
So I just wanted to link this to what was just going on with Hurricane Laura, where they're talking about these extreme sea walls coming in, like 20 feet, these record, I don't know if it even got that far, but that was a potential 20 feet storm surge. You can't survive. That's what they call the unsurvivable. But these storm surges they keep getting larger and more. The Weather Channel is like, oh my God, we haven't seen this before. And then they don't say climate change or mention anything. They just say, like you said, they're graph readers. Yeah, we're going to have 20 feet. But, is this because sea level rise is increasing these storm surges? I mean, if the water rises, it's going to create more and more damage, because essentially the earth is taking back.
Basically, you got a couple of things going on here. You've got, you're putting more energy into the water system, into the planet, but you got a lot of energy being absorbed by the oceans. That's going to fuel more powerful storms, like we just saw with Laura being a Cat 5 Okay, so you're gonna have and when you ever have a cyclonic system, storm, what have you, as it moves along, it's always going to push a bit of water in front of it because that's what wind does. Acts on the surface of the water and pushes on the water, makes a little bit of a piling up. Now, depending on where you are with the tidal cycle, will determine how high that is. But the more powerful the wind is, yeah, you're going to have a higher wall. So in certain locations, it is not inconceivable to have a high storm surge. But a lot of it is, from adding heat to the oceans, increasing the sea level. Adding heat to the ocean has thermal expansion. That alone will also increase sea levels, and then you have more powerful storms. So you put all these things together, and yeah, you're gonna have a lot of energy to distribute.
I think one
That
of the
that,
reading, yeah, go ahead.
that's what cyclones are all about. They're really this energy distribution.
Correct. Yeah. I mean, well, at least in the Atlantic hurricane season, they come from off the coast of West Africa, and there's always like this moisture, and then it just builds up because like you said, the oceans are getting warmer. And I was gonna say that going in the Gulf, it was like 87 degrees. That's why it was like rapidly intensifying. Was another rapidly intensified storms are a consequence of climate change. I've read that a while back.
Yeah, I mean, Laura went from a Cat 1 to a Cat 4 to a Cat 5 within hours. It's like crazy. I mean, it went from a Cat 1 with a very poorly defined eye to a Cat 4 with a very strong, tight, close eye in like 3, 4 hours. It was incredible.
Yes, very incredible. And like we've said before, it's hitting these areas, these low-lying areas with all these dirty industries and factories, and it's just a whole mess. But all these things are just, the like they're all connected, I guess, is where I'm going with this one. Is just we read things about Antarctica, we read things about the Arctic. I mean, they're far away if you don't live there, but we're all affected by what's going on in these places, and it's whether or not you think it isn't, it is. I'm trying to make that point.
Well,
Um,
it's part of the reason why I did that oscillatory system of videos was, yeah, you have ENSO going on, but ENSO impacts what's happening with the PDO, which impacts the AO, the NAO, the AMO, all these what called teleconnections. We actually have a term for that it all ties together. And people basically been poo-pooing me, saying, well, up here in Sweden, in Scandinavia, it's cold. We still have the sea ice, this, that, and the other thing. And I'm like, it's cooler in Sweden because the Gulf Stream is slowing down because of all the water added into the Gin Sea. So the conveyor belt is slowing down. So if that slows down, the Gulf Stream doesn't get up north to distribute its heat.
Interesting. Yeah.
And that's more of a regional situation as opposed to planetary situation. That's what's going on there. You look at the rest of the Arctic Ocean and the sea ice is falling off.
Exactly. Is the bipolar polar still in effect?
It's like 3/4, 1/4.
Okay.
According to according to what I just saw, the latest diagram, Siberia is now cooler than normal. It did a complete reversal. And now the rest of Eurasia, the rest of the North American side of things is warmer than usual,
So it's
including
split.
Alaska.